So there's hundreds of experiments on the space station in all kinds of different domains, but some of them study specifically climate change. There's one on the outside of the space station that's called ASIM, is built in Denmark, and it's an experiment that looks at the phenomenon that are occurring in the upper atmosphere when there's a thunderstorm. We know there's lightning strikes going down to the ground, but there's also some phenomenon occurring and some interactions occurring in the atmosphere. And this is a phenomenon that's not really well understood, but we think it plays a major role in our general climate. And as thunderstorms are going to be occurring more and more with climate change, we need to understand this phenomenon. And this is one of the examples of a specific experiment dedicated to climate change. But also more generally speaking, with my mission, on my mission patch I have the Sustainable Development Goals from the UN on my patch, and the goal is to really raise awareness to the importance of acting to reduce poverty, inequality, to improve health and education, and really all the aspects of those Sustainable Development Goals are tackled using a space mission and a manned space mission, a human space mission as an example. So the aspects of climate change that we can see most directly in space, there's many really. We can see the glaciers melting. We can see the glaciers reducing inside, over the course of several missions, not just in 6 months, but astronaut after astronaut on the space station take pictures. We can see this. We can see air pollution. We can see forest clearings. We can see water pollution. But really, also what we see more and more are those violent weather phenomena, the thunderstorms, hurricanes, landslides. All this can be observed from our vantage point, from our crow's nest, and this is getting more and more concerning, so we need to act now. There's a lot of activities that are easier to do on the space station than on Earth. For example, if you're putting your clothes on in the morning, you can just jump into your pants. That's absolutely easy to do on the space station. You can't do that on Earth. I don't recommend because there's a chance of falling and injuring yourself. Things like this, moving around big masses, like heavy masses, is obviously much easier than on the ground. But on the other hand, the seamy side there's also stuff that's much more difficult to do in space than on Earth. Eating, dealing with food, doing hygiene, managing, floating things. It's kind of a trade-off. Some things are easier, some things are much more difficult. So to prepare for a mission, it takes a lot of time. You have to know the ISS inside out. As you see around me in the Columbus module, it's a very, very complex environment, lots of technology. You have to be able to understand what's going on. You have to be able to fix it when it breaks. So there's a lot of studying, classroom studying, hands-on training in the mock-ups with the systems individually or put together as a whole. We do a lot of physical exercise. You have to be in good shape to withstand the accelerations of launch and re-entry. And also you have to be in good shape because you're going to be losing muscle mass and bone mass over the course of a 6-month mission. So you have to be in the best shape when you launch to be in the best shape when you return to Earth. We have to learn Russian to communicate with our Russian crew members up here, and also flying on the Soyuz or working on the Russian segment. We have to do survival trainings just in case the return doesn't go well. We land somewhere when there's no resources. We have to be able to figure it out on our own. And then survive with just what we have. So there's really a lot that you have to do. We have to learn spacewalks. We have to learn to fly the robotic arm. We have to learn our spacecraft, the Crew Dragon. It's like an airplane that you have to control and learn and be able to interact with and react to the failures if they happen. So it takes a lot of time to be ready for a mission. But after a few years of hard work, then generally you get a chance to fly to space and you live your dream. What we do miss most from everyday life when we're on space station, it's mostly your friends and family, all the people that you left behind. It's not easy to be on your own. We're as a team with our crewmates and we're good friends, but it's still not the same. So some people live, their parents, their spouses, their kids, their friends. So that's not easy to deal with for 6 months. 6 months is a long time. But thankfully we can call them on the phone, we can write emails, they can sometimes send us surprises or small packages when there's a cargo vehicle coming up and bringing us some resupplies. So we're not completely isolated, but that's, to me, is the most difficult. Also loss of your freedom or the lack of freedom. You're restricted to, a common space. Is very confined. You always end up going to the same places, doing the same thing. So it's very, very repetitive. There's a routine. So if you like to do different things, the big outdoors and go out and meet new people and do new activities, then that's not going to be easy on a space station. What tools to make measurement regarding Earth observation? Also, there's plenty of tools on the space station to make measurements regarding Earth observations. There's payloads, scientific payloads on the outside of the space station. There's one, it's called the Orbiting Carbon Observatory, OCO. It's a NASA Earth system. And its sensor uses sunlight reflections through the atmosphere to measure variation in atmospheric carbon dioxide, which is obviously a big factor for climate change. There's also EcoStress, also a NASA Earth science payload that uses a radiometer to measure plant temperature and how plants use water, which is something we must understand to be able to manage water in the areas when it's scarce. Also, we deploy regularly some miniature satellites. It's called nanosatellites. We have a couple airlocks on the space station that we can deploy them from. It's really cool. It's like shooting satellites out of the space station into their own orbit. They're being built sometimes by small companies, by universities, by students, and most of them have a payload or a function that has to do with climate change and doing some measures about Earth observation. Finally, I think we're doing Earth observation, the astronauts themselves. So we have a wide array of big lenses, long lenses, and by taking pictures after picture after picture, it's not as good as an observation satellite. But if you put together all those pictures over the course of many years of Earth observation, you have a set of data that you can mine, that you can use to have some conclusions. And finally, you can make some measurements from the space station. We have those small mini computers called AstroPi, and they have a set of sensors. We've set one up not so long ago to take pictures of the Earth. And there's also a payload that NASA calls EarthCam, and it's controlled by students. And you can actually, from your classroom, take pictures of the Earth. I think that's pretty cool.